Fritz Egger started off with, he had a sawmill and he saw all of the waste that was coming from the sawmill and thought that it's much too valuable. The waste is much too valuable to throw away. So that's how we actually got into particle board business. So starting in Austria, we've got 22 plants around the world. We have a number of products that we obviously manufacture products here at this facility, but then there are a lot of other products from other plants that we sell into the United States. Brilon, Germany, which manufactures our Perfect Sense product. The laminate products that we manufacture, that we sell, are manufactured and made in Gifhorn, Germany. And then all of our edge banding is manufactured in a location called Gebze in Turkey. This is actually the second largest edge banding plant in the world under one roof. And then in addition to that, we also have a plant in Concordia, Argentina, which manufactures some of our MDF, but then we also sell molding into like Home Depot and Lowe's and things like that. So truly a massive global company, and still family owned to this day, still family run. And yeah, we've got lots of interesting stories to tell, and certainly a lot of product that you're going to see as we kind of go through the tour.
The recycling plant is where we're headed now, and that recycling plant runs off of either two materials, either the material that we got from timber pack or scrap material from somewhere in the process. Either scrap from the sawdust line, scrap from wet chip, scrap from the Connie, or rejected material from laminated or raw board area. So we don't waste nothing. Like, I came from the metal industry before I came here, and in the metal industry, you got one attempt of fixing it if it's not correct. Here, if it's not correct, because we can run it right back through our recycling plant, we don't throw nothing away. So we're always constantly improving.
This is one of our future investments. These are actually the footings for a power plant, based off of some of the wood waste and things like that that we might have that might otherwise go to a landfill. This will eventually be built up so that we can actually burn that material off and basically create our own energy to help us be a little bit more self-sufficient. Probably at least a few years out. But that's the other, to kind of Joseph's point, that's one of the ways that this plant was developed, was to basically be constantly upfitted and kind of upgraded in a variety of different ways.
So the first thing we'll pass is our metal recycling bin. This is from your first ferrous separator that the material goes through, and it catches a lot of, it catches 87% of the metal that would be in the product. And that other 13% we'll get as we break the wood material down further. So this pile directly in front of us, that's actually a mix of third quality material from the plant and material that came from the recycling center timber pack, where you could see broken pallets, see the blue in there, and then pieces of particle board. So we'll break it up with the excavator, anything that's too big, and then from there a wheel loader will start the recycling process. All right, so the wheel loader, just like we dumped in the push floor earlier, we'll dump into that hopper right there, that gray right in front of us, and then the material will go through this shaker table. So an operator would stand right here and he would inspect the material coming through. This whole table would be shaking and gyrating. It shakes to keep the material flat, and so it goes through the process evenly and not just all the bulk in the center or to the left or to the right. So the operator will pull out big pieces of metal because the metal will break the grizzly machine. And then they'll also pull out big pieces of paper and plastic. That's what these two trash bins right next to them are for. One's for metal, one's for plastic and paper. And when they get full, we have hoppers right outside this window for them to dump them into. And then they dump them as those hoppers fill up. So let's say hypothetically metal made it past the operator. This metal detector will go off. It'll stop everything from shaking. It'll stop the grizzly from going forward. And then we'll have to go in here, get the metal out, clear the alarm, and then turn it back on. But it's just a safety precaution to protect the machine. So the material will go through here. It'll go through this grizzly. We call it a grizzly. It's a grizzly machine. What it is a big shredder. You ever seen a video of like a shredder just eating stuff? That's what it is. There's discs, a bunch of discs lined up on each side, and they're just constantly rotating. So then the material will come down. It'll go up. It'll go through a ferrous separator, and it'll go to the buffer silo. So now that we got material in the buffer silo, this is where we start the process. So it'll come out of that buffer silo and go up that diagonal, exactly, that chain conveyor right there. So it'll drop down and it'll go through a rotary valve, and the rotary valve will like inspect the material. If it's good, it'll just move it along to the next step of the process. That's why you have two different chutes coming down. If it needs to be broken down, it comes right here to this big machine right in front of you. This is what we call our ballistics mill. And it'll take bigger material and break it down to smaller particles. If it deems it too big, it'll kick it out and reject it into that hopper over there. But all the material went through. Now it comes down, rides this chain conveyor back up to the top. Now it'll go through a Dynascreen. Same thing on the Dynascreen. So this right in here is sawdust material. So we don't use this to make our boards. Like this is like truly dust. These are too big. They've already went through the ballistics mill. This is too big. It's already went through the ballistics mill, and this is how small we got it. All right, so the material's got to be smaller than that. We can run it through again, which we do 9 times out of 10, but it's like a 60-40 shot. 60% that it will go through, 40% that we might have to do it again. That's what they consider bad. It's either too big or it's dust. So as it moves through the Dynascreen, then you go through your first, this yellow machine right here. There's 2 of them actually, 1, 2. So one's a ferrous separator and one's a non-ferrous separator. So your ferrous is all your metallic objects. Your non-ferrous could be your plastic, your rocks. It could be metal objects that's not magnetic. So that's why you have both your ferrous and your non-ferrous separator. If the material's already at the right size, it'll move to the next operation, to the bender screen. If the material made it past the ballistics mill and it's too big, but it made it through the process, from right here, it'll get kicked back to the water bath. The water bath, the material, the wood will sit in water. Anything but wood will fall to the bottom. And it'll also soften up that piece of wood. And then it'll go back to the buffer silo to go back through the process. Now the material goes back up again, and we come back down. This is, we've already went through the majority of the recycling plant. So right now, if it's good, on the first rotary valve, it'll send it to the vendor screen. If it needs further breaking down, it'll keep going through. This yellow machine you see in front of us is what we call the Cyclops. And the material lays, goes across the shaking table to keep it flat. And it's got digital eyes and lights looking at the material. If it sees something that's no good, it'll shoot a shot of air, compressed air, and it'll blow it out to a reject. From there, if it needs to be broken down even further, our last step of breaking it down is this machine right here, which is our fines hammer mill. So we had a ballistic mill, now we got a fines mill. The fines mill is for finer particles, that square machine right in there. So this is the last step of breaking material down and getting it to the size we needed for the recycling plant. So this machine right here, what we call the bender screen, okay? This is a brand new investment. I believe it was like a $2.7 million investment. And what the main objective of this machine is to remove dust from the sawdust, from the wood chips, okay? So both the fines mill material will run down underneath and back up, and then everything that was deemed good through the first other two steps is going to go through, and it'll meet, and it'll go all the way to the top of the slide, and it'll come down the bender screen to the bottom, all the way down to the screw. Yes. And so then now it runs over and to the wind sifter. The goal is to get all the dust out, and then the dust will go back here to our exhaust system and then to our energy dust silos, which currently one of the dust silos we do sell off to get rid of. In the future, we'll burn it for energy. And some of the dust already we do burn for energy for one of the dryers for material. We're not set up to do all the dryers yet, but they will. So as far as combustible goes, so we're constantly cleaning, housekeeping. So they clean this once a shift every day, or twice a day, because there's two shifts. If you didn't, there would be a layer of dust, like you said. But then we have ATEX systems and sprinkler systems and fire suppression systems throughout the whole system. So the building itself is designed with sprinklers, all right? So you have a whole sprinkler system for the building. Then the unit, all the ductwork, all the high pressure exhaust, the round pipes, your high pressure exhaust, and all the rectangular and square stuff, duct is for material running through on a chain conveyor. All right, every single one of them, you can actually see it right here, this low one. So this is a sprinkler system on the material. Yes, so we have it, and you have two lines. This one's water, this one's dust. All right, so the water line's empty as of right now. It's just got air pressure in it. If the seal goes off like your normal sprinkler head would, if that goes off, the air will come out and it'll send off a sensor to the pump house, and then water will squirt out. The one with dust, when this goes off, the dust will send out the dust like on a fire extinguisher dust and suppress the fire. Yep. So we've got our fire protection incorporated into our equipment and in the build and the facility. We also, for fire protection, as that goes, we also have our motors. Every single motor, every single bearing has a temperature sensor on it, because you can also get fires that way as well from the heating up of the actual motor or the bearing. Yeah. So we're almost done with recycling. almost. So the material, we extracted all the dust in the bender screen. We moved through our last non-ferrous separator over here to try and remove any plastics and impurities that we didn't get out yet. And that's what comes down right here. And it'll shoot out to those dumpsters. This is the last process of recycling. This is our wind sifter. We have wind, negative air pressure moving around inside of there, and it's moving the material. If it's good material, it gets pulled up through. If it's too big of a piece, the weight, it'll pull it down. It'll ride the screws all the way over and out, and then that'll go back to the water bath to go back through the process again. If it is good, after it goes through the wind sifter, it will ride these conveyors. It'll finally make it to the edge, over, and then it'll go all the way up, across, and sit in 158 until it's ready to be dried. We also do planned maintenance once a month on every piece of, on every area. That's the surface layer. See, it still looks like wood chips. And I'll grab a hand of the core layer. So you can see the difference in the two, but they all still look like just sawdust, you know, that you would have from your chop saw scrap. This product right here is wet, ready to be dried, and turned into particle board. See them knobs? Those are belt tracking sensors. This right here is a weight sensor. So I can tell how many tonnages of material I'm moving through here an hour. So we are fully automated. This area right here, just since we're in it, is the transfer area. We call these the transfer elevators because here's your surface layer, your core layer, and that one running right there is recycling. And you see it's got another, all three of these yellow eyepiece are magnets. It's just another opportunity for us to get impurities out of the material. If there is something on there that shouldn't be on there, it'll go on top of here. It'll go through this little transfer duct, and it'll get kicked back out, back that way to the left. So if the sawdust line isn't working, we can run sawdust through the eco-pulser. And vice versa. If the wet chip's not working, we can go through the eco-pulser.
There's backup upon backup upon backup.
Yes. So we keep running product. Even if we had only one dryer running, we can still make particle board. So this is the dryer. This is actually the exhaust for the dryer. This is for the core layer exhaust. That over there is your surface layer exhaust. And so everybody saw that condensation coming out of that stack, right? That's all it is condensation. So we recirculate the dryer air as it burns and it keeps drying material. As it comes back through, it'll go through this silo looking thing right here is the wet electrostatic precipitator. So inside of there, the best way to visualize it is this honeycombs, layers of honeycombs. And in between each honeycomb is a wire and a weight similar to like an old-fashioned window weight that used to be in the wall, holding the wire down. All right, so as this air keeps circulating, every 90 seconds, that wire does an electric kind of pulse. And what it does is it pulses on the molecules in the air. And it'll actually make them into like a dust form and not just hot air moving through. And then every 180 seconds, it'll precipitate in there and like wash the honeycombs off. So then that dust will fall. That's part of the dust that we actually burn for energy. Then the air's potentially already clean now to be exhausted, but we do even more than that. We run it through a whole 4-stage regenerative thermal oxidizer, RTO, filtration system, which are these four, 1, 2, 3, 4 gray, dark gray things right there. Those are your RTO systems. It's a big, huge filtration system. And that works on a timer as well. Every 180 seconds, it switches direction of the airflow. So instead of going from A to B filter, it'll go from B to A filter. Um, and it goes through a series of 4 different filters, like a figure 8 shape, on each different 4 towers. Then it'll finally blow out the smokestack condensation. So our core layer dryer, that's what you see this drum rotating. It because the core layer material um, is a bigger piece of material, we've actually got to clean the inside of that every 2 weeks. After the material dries, it'll sit in these retention silos to cool off. That's what those are, those silos. From there, it'll go to an oscillating screen to shake. Those are the shakers, yep. And it'll separate into 3 different things. Either it's good, needs to be broken down more, or it's going back to recycling. From there, if it needs to be broken down more, it'll go through a hammer mill, and like in front of that silo underneath there. If it doesn't need to be broken down more, it goes right to the air grader into the buffer silo for the Connie. Now we're in the buffer silos for the Connie. We're gonna start making boards.
We've got our, this is our glue kitchen, and this is where we kind of start the forming line. You'll see in this building too, these beams aren't just for aesthetic purposes. Um, those are actually, because if we had steel or if we had aluminum, if we had for some reason a fire or something like that, they might melt, where these will actually maintain their structural integrity. This is also the area that we talked about where we have the very, very sensitive fire suppression system, because this is where we're actually starting to get into forming line and then the actual Conti press as well. So, I mean, basically, we've got 3 layers to make raw board, 2 surface layers, and then the core layer, and that's essentially what's being formed or created with all of these materials here. Well, what
It is.
you've got surface layer on the bottom, core layer, and then another surface layer.
Oh, I see.
So that mixed with the resin from the glue kitchen is where we're actually going to start to see the beginnings of product. Because once we start to go up to that control center, you're going to glance over, and if everything's running properly, we're going to have basically a wood cake that will eventually be pressed into raw board. And again, with the quality checks, like that orange and gray piece of material right there is an X-ray machine that's checking for anything that made it through the other part of the process, but then also is looking for voids in the material and really anything that could kind of compromise the quality of what we're eventually going to turn into raw board. So just past the X-ray machine, just in case this does catch something, where those yellow gates are, we also have a dump point. Just so if this machine catches something, material is going to start dumping before it actually gets into the press. And then it'll basically go through the process again to be purified and checked. The only other reason typically why we will dump material is you'll notice you've got the material running and then you've got blue on either sides. So what we're eventually making are the master panels, which are twice the size of the material that we're actually going to sell. So if we're selling a 5x9 board, the master panel is going to be 10x18. Right now, we're not necessarily running super efficiently because that's a 10-foot wide Conti. So if we wanted to switch over material, we might dump to kind of reset it and basically get it so that we can run wider material. But the other thing that you'll notice is there's almost no people here. So the largest single staffing wise, the largest area of production is maintenance. Egger is we're maniacal about safety and we're maniacal about maintenance. So that's why this equipment is so well maintained, is because we have the staff to be able to do it. So one of the other things about Egger is that's one of the beauties of having a company that has 22 plants is we use a lot of the same equipment, but then we upgrade as we build out or outfit new plants. So when we do major maintenances, a lot of the techs and stuff like that come over here from Europe. They know this equipment. They help us to basically they help our maintenance team to basically service it and keep it running properly. So this is where it's going to get loud. So we went from that thickness to this. So we've got diagonal cut saws that are basically cutting down these master panels. So you'll notice as we kind of walk out, there's a sheen to them. So they need to be cooled first, and then they can actually be sanded down or actually kind of roughed up. These actually go to our star coolers, and you'll feel a lot more heat in this area. We'll duck in and then duck out. Go into our star coolers. We have 3 star coolers. A lot of other manufacturers only have 2. Basically, the boards stay on here for 15 minutes at a time, and they cycle over like a clock, and then get handed over to the other cooler and continue to cure as they go through the process. And then they basically go through and then get sanded to be roughed up.
The boards coming in are 270 degrees Fahrenheit. When they're leaving, when they go out the other end, they're still every bit of 150 degrees Fahrenheit.
But what you're feeling is the heat dissipating off the boards.
Yes.
You can feel the heat off the boards as they come through. So when they come back, then they're ready to be sanded. So this is after they've cooled down.
Saw how the rollers were diagonal? They're like that to push the board into one direction or the other, left or right.
So these are actually the sanding belts that are used to rough them up.
This is our roll board shipping area. That's our raw board shipping area.
So we talked about maintenance, we talked about safety. We also have to talk a little bit about quality. So this is one of our quality check stations where you see the actual cutouts. And so what we'll do is we'll actually take samples of both raw board and then also finished product, cut them out, and then we have an on-site quality lab who's testing for tensile strength, for on the finished product, exposure to liquids and things like that, and basically making sure that all of the product that's going out is basically meeting Egger standards. In addition to this, sometimes we'll get competitive material and we'll also test it here. And then we also have another lab that's based in Europe where we'll send competitive material there as well to basically test and make sure that we're maintaining the standard. So this is our saturation line. And as I mentioned, kind of Egger tradition, the first board that came off of this line was September of 2023. So prior to this line being here, we used to actually have to import papers to be able to be used in the process. And as we kind of go through this line, you'll see why that's not the easiest thing to do. It's much better for our production to be able to actually manufacture the paper here. So we've got the actual rolls of paper over here, and then we have this line itself. And what we're doing is, what we're running right now is W1050, which is one of our white decors. Um, and so we've got two chemical baths that the paper is essentially going through to be treated. Goes through the first bath here, and then is basically pushed by air to the second bath. And this space itself, this on its own was about a $21 million investment. And again, we have the capability, when the market demands, to build another one directly on the other side of this building as well. So runs through, pushed by air, goes through a second chemical bath.
But that second bath is always melamine.
Yeah.
Which is plastic, essentially. The chemical melamine is plastic. You know, like your plastic spoons, the throwaway spoons, it's made out of melamine.
But when people years ago referred to this product as melamine, it was based off of the chemical itself. So after it's fully treated, the paper comes down, and this is where it's actually cut to size based off of whatever it is that we're actually selling. If you take a piece and put it between your finger and your thumb, and basically press it down, you start, if you kind of press on it, just with your body heat and the pressure alone, start to feel it's tacky, and it starts to have some true adhesion. We're basically going to take the raw board that we've already seen, and then that's where we get the actual thermally fused laminate. We're going to duck back into raw board production, because after those master panels have been sanded down, this is where they come. Crane storage, we've got, if you kind of look between the lines here, this is where the master panels can either become raw board bundles or can be cut down and moved over to upgrade. So if this were entirely full, and this does look pretty full at the moment.
It's about 97% full.
Yeah, this is about 3 to 4 days worth of product for our customers. So when we go into major maintenance periods, we basically kind of stock this and stash products here. So then we can bring down the plant, still serve our customers, and then kind of fill it up as needed. So we've got two cranes that are operating, one which is a larger crane that actually moves the bundles themselves, and that's almost an entirely automated system. And then we have another smaller crane that's responsible for the wood runners that are separating the bundles to basically put them in place. From here, we're moving on to the upgrading area. And so this is actually the largest, tallest building in Davidson County. And one of the things that's really, really nice to do when you happen to be building the tallest building is to gift the local fire department a brand new ladder truck. So just in case something does happen, they are actually fully and properly equipped to kind of take care of the situation. Did we argue about this before? 120 feet? I feel like we checked this, or we talked about this.
We did talk about this. I think it's 120 feet tall, and it's 100 feet in the ground, the structure itself. We're taking material out of high bay right now and running it down pack line 2 to repack as raw board.
Oh, there you go.
That's why we're seeing it in the reverse option. So the material, grabbed it from somewhere in here, put it over to the transfer conveyor, and then it's going to move on to the carriage, and then the carriage will slide on down. And like another thing that's cool, if you look at this carriage, right, you don't see no power wires or power lines anywhere. So it's running off of the connectivity of the rails. So the rails is allowing the 24 volts to make a loop and then allowing the power to run. Like you could step on it, it won't shock you. It's got to make the bridge. And then the red lines are emergency cords. So if you happen to be inside of there and you touch that, it'll stop dead in its tracks.
This is climate controlled for the treated paper that we saw from the saturation line. So same depth and certainly same height as the two lanes that we just passed, but this is climate controlled to make sure that all of that paper is acclimated and basically ready when it needs to go on to upgrade.
And the paper has a 6-month life cycle. So we've got to use it within 6 months.
These are our upgrading lines, KTA, KTB, KTC. We have investment plan, as Joseph had mentioned, for another line, which will start to go in on the other side of this building. So we kind of start at the end of this process, just kind of how the tour gets us. But this is good because this is this is how we get continuous production, is because this system is designed where the product goes here, and then on the other side of this wall is our logistics area. So it can basically go from here with one of those carriages directly into logistics and be packaged and be ready to ship out. As we mentioned, the first board that came off of out of this particular plant, finished board, was September 8th, 2020. Um, Certainly right at the height of COVID, but not a bad time to be in business at the time. Um, we can duck into logistics real quick and just stay on the top steps to kind of look at everything. So you'll notice a couple of different things here. Number one, when you look out across the product, anything that has a topper is going to be an upgraded product. Anything that does not have a cardboard topper on it is basically raw board. So we've got raw board, we've got finished product, we've got some mixes in the stacks. We do also manufacture our own runners for the bundles themselves, again, keeping with sustainability. And then in addition to the regular raw board and finished product, a lot of our specialty products, like our edge banding and our Perfect Sense products, are also in our warehouse along that side of the building. Finished bundle is basically going to go and into logistics and be packaged. So as we're at the end of this process, we've got a little bit of a cooling / curing period toward the end before it gets bundled. But we do before it gets to that point, we do also have a visual inspection station where people are actually physically looking at the board to see if there's one final catch, or if they happen to see something on either side of the board, they can stop it and basically catch it before it goes out to our customers. So this is the actual short press where the raw board and the paper are actually fused together to be upgraded. You'll notice as the boards come out, there's a bit of an edge on the paper, and that will actually be cut down on the other side of this catwalk. But that's basically where all the materials have been combined, and then this is where it's fully finished, where the paper is essentially routed off the edges. And you'll see when they do shutdowns like they have on line B, like they'll use an air compressor and they'll blow out like all of the stuff and then get it cleaned up so that it continues to operate and work efficiently. But that tall bank right there is essentially the library of plates. So for each decor or for each texture, we have 3 different plates, one for the top, one for the bottom, and then one that's a spare. And the plates themselves are generally between $90,000 and $150,000 a piece. So those are purchased and then basically sent over. We do also have a process where when we get a new set of plates that are sent to us, we have to go through a process that we call commissioning the plates, where we make a new board, and we have to send that board to Austria for it to be evaluated and quality checked before we actually get the go ahead and the green light to say yes, this is good for production. You can go ahead and use it.